Hello, we're going to go through paper 1 revision for the physics AQA exam. Let's start with the different types of energy that there are. So chemical, so that's a chemical bond that you might do lots of breaking in chemistry. There's kinetics, that's the posh name for movement energy, or something with a velocity or a speed. Sound, self-explanatory, and gravitational energy, or gravitational potential energy. So as you go higher up, you gain in gravitational potential energy. There's also elastic potential energy, so if you stretch a spring or an elastic band and then it pings back. Posh name for heat energy is thermal energy. Of course, there's nuclear energy, so that's with nuclear fission or fusion, and electrical energy. So we don't tend to use the word electricity in terms of energy, we say electrical. And then there's light. Something that's important with regards to energy is the conservation of energy, and that is that it cannot be created or destroyed, just transferred from one form into another. And the key word there is transferred. Linked to energy is work done. So we use work done when energy transfers from one form of energy into another. So for example, when electrical energy turns into heat and light, work is done. However, there is an equation, work done equals force times distance moved in the direction of the force. Because work done is a type of energy, its units carry on as joules. Force is always in newtons, capital N, and distance in meters. If we look now at gravitational potential energy, that equals mass times gravitational field strength times height. And again, because gravitational potential energy is a type of energy, it's measured in joules. Mass is in kilograms, gravitational potential energy newtons per kilogram, so N/kg, and height is measured in meters. You get given the value in the exam, but generally speaking, the value of G on Earth is 9.8, or can be rounded to 10, sometimes newtons per kilogram. There's another equation that links mass and gravity together as well, and that is weight. So weight equals mass times gravitational field strength, or W equals mg. The thing to remember here is weight is a type of force, so it has the unit of newtons. People often get confused between mass and weight. They're used wrong in day-to-day life. So what do you weigh? Well, it should be, what is your mass? So anything that's measured in kilograms is mass, and you then have to multiply it by the gravitational field around you, and that will then turn into a force known as your weight. Into 2, you could write gravitational potential energy equals W times height, or weight times height. It's the same equation. Often linked to gravitational potential energy is kinetic energy. One will transfer into another. So for example, when you go to the top of a slide, you gain in gravitational potential energy, and then when you fall down the slide, that then converts or transfers into kinetic energy. The equation is a half times mass times velocity squared, and the thing to remember is it's only the velocity number that gets squared. We said earlier that kinetic energy is a type of energy, so that's measured in joules, mass still kilograms, and velocity is meters per second. People often find it hard to rearrange the equation, so what I've done here is done that for you, and it's just a case of learning it if you're unsure how to rearrange. So mass equals 2 times kinetic energy divided by v squared, and velocity, it's square root of 2 times kinetic energy divided by mass. On to elastic potential energy. The equation for that is very similar to kinetic energy. It's a half times spring constant times extension squared. As an aside, there's another equation which mentions spring constant and extension, and that is force equals spring constant times extension, but that equation is in paper 2, F equals KE. So for this one, just focus on elastic potential energy for now. Let's look at efficiency. The equation is the useful output energy divided by the total input energy. Generally speaking, it's the small number divided by the big number. The maximum efficiency something can be is 100%, so it cannot be any greater than 100%. So the higher the efficiency is, the more energy that is transferred into useful energy. A light bulb is typically 10% efficient. That means that 90% of the energy is wasted as heat, only 10% is used as light. If you know the energy, then you might be able to calculate the power. Power is the energy transferred divided by the time taken. In other words, how quickly you transfer energy from one form into another. The unit for energy remains as joules, and time taken is seconds. Therefore, the unit for power is joules per second, or more commonly known as watts. So a 60-watt light bulb would transfer 60 joules of energy every single second. It's also important to understand the prefixes involved with this topic. The main ones with power are the kilowatt, the megawatt, and the gigawatt. In 1 kilowatt, that's the same as 1,000 watts, or times 10 to the power of 3. The megawatt is 1 million watts, so mega is million, and that's times 10 to the power of 6. And finally, the gigawatt is 1 followed by 9 zeros, or 10 to the power of 9. You've now reached the end of the video. Thank you for watching. And as ever, if you have any questions, please get back to me. And don't forget to press the subscribe button so you get alerted for any other videos that are made. Thanks for watching.